welcome back. This is Mrs. Rewrite with Advanced Geometry. Today's lesson is 4-1, Apply Triangle Sum Properties. You should copy the for your notebooks on page 207, 208, 209, and 210. Classify triangles by sides and by angles. Classify the triangular shape of the support beams in the diagram by its sides and by measuring its angles. Alright, so it's very faint because textbook publishers are really known for making everything faint, but you can, if you look really closely, there's a tick mark here and a tick mark here. So according to its sides, we have two equal sides. So if we have no equal sides, then it's going to be scalene, right? A triangle with no equal sides is scalene. A triangle with two or more equal sides is isosceles, and a triangle with all equal sides is equilateral. Okay? And then it says to measure its angles. They actually want us to break out a protractor. So if I take this protractor and I put those crosshairs perfectly on that vertex and I line up that bottom 0 degrees with the leg, then I can see that I'm at approximately 55 degrees. So you can see it's either 125 or 55. Well, this is definitely acute. It's 55. You're going from 0 up to 55 degrees. So that base angle is 55 degrees. Let's look at the other base angle. Because it's isosceles, they should be the same. So let's look. Let's check it out. It's also 55 degrees. And then we can check out this top angle. So I put the crosshairs on the vertex. I need to rotate this so that my 0 degrees is lined up with one of the legs. And then I'm looking to see where this falls, and it falls at 70 degrees. So does this make sense? Let's see. So we have 55, 55, 70. Do those add up to 180 degrees? Because triangles add to 180. They do. So we know that we didn't mess anything up. So, in terms of classifying triangles by sides, so we know when we're classifying triangles by sides, we have scalene, no equal sides, isosceles, two or more equal sides, equilateral, all equal sides. In terms of classifying by angles, if all angles are less than 90, it is an acute triangle. If you have a right angle, 190-degree angle, it's going to be a right triangle. And if you have one angle greater than 90, less than 180, it will be an obtuse triangle. Okay, obtuse. So you have acute, like a cute little baby, all small. You have a right triangle or you have an obtuse triangle. Can you have more than one obtuse angle in a triangle? No, because if it's greater than 90, two numbers greater than 90 add to more than 180 right there. So you cannot have two obtuse angles or it will not close. It won't be able to be a three-sided object. Alright, so it has a pair of congruent sides, it's isosceles, and it's acute. So it's an acute isosceles triangle. Classify the triangle by its sides. Then determine if the triangle is a right triangle. Alright, so classify it by its sides. Well, we need to know what are our side lengths. So just like yesterday, remember yesterday we did Pythagorean theorem? We showed the video from vocabulary, Pythagorean theorem. Haven't you heard? When you know two sides, you can find the third. A squared plus B squared equals C squared. Right? Solve for the square root, and you're almost done. Alright, so if I make a cute little right triangle out of this, because I'm not a fan of the distance formula, we have 2, 1. 1 squared is 1, 2 squared is 4, 4 plus 1 is 5, so we have square root of 5 for the distance here. Or you could do x2 minus x1 squared plus y2 minus y1 squared and take the square root. So like 0 minus negative 1 squared plus 0 minus 2 squared and take their square root. And you're going to get the square root of 5 that way as well. So right here we have square root of 5 for this measurement. Over here, let's make a right triangle with this side of the triangle. We would have a 1, 2, 3, 4, 5, 6. By 1, 2, 3. 6 squared is 36. 3 squared is 9. 36 plus 9 is 45. So over here we have the square root of 45. Can we reduce that radical? 9 times what? 9 times 5? Yes? Square root of 9 is 3, so it's really 3 rad 5. So we have rad 5, 3 rad 5. So let's clear this up and just kind of make it nice and neat. So rad 5 and 3 rad 5, right? Now let's do this one. This one would be a 1 by something. 1, 2, 3, 4, 5, 6, 7. A 1 by 7. 1 squared is 1. 7 squared is 49. 49 plus 1 is 50. So the square root of 50 is 25 times 2, or 5 rad 2. Are any of these measurements the same? Are these distances the same? So we know it's scalene. All different sides. Now, is anything a right angle? Well, perpendicular lines intersect at a right angle, correct? So let's look at this slope. Down 2 over 1. This has a slope of negative 2. What about here? Down 2 in the negative direction, 1, 2, 3, 4. Right? Down 2 over 4, or down 1 over 2. This is negative 1 half, but it's negative 1 over negative 2, so it's really just 1 half. Is 1 half and negative 2 negative reciprocal slopes? Yes, therefore this is 90 degrees. So this is a scalene right triangle. Does that make sense? They have negative reciprocal slopes, so it's a scalene right triangle. Do you guys see how this one has a slope of down 2 over 1? Negative 1 half. This one is rise over run. So we're going up 1 over 2. Up 1 over 2. This has a slope of 1 half. Up 1 over 2, up 1 over 2, up 1 over 2. Down 2 over 1. Negative 2 versus 1 half. They are negative reciprocal slopes. It is going to be a right triangle because they are perpendicular. All right, so they're still just solving this using the distance formula. They're doing those slopes. They're seeing that they have those negative reciprocal slopes. Therefore, they are perpendicular. So it is a right angle, making it a scalene right triangle. Draw an obtuse isosceles triangle and an acute scalene triangle. So I want you guys to kind of just take a 30 seconds or so and draw what you think an obtuse isosceles triangle looks like and what you think an acute scalene triangle looks like. So the first thing I want to guys ask you is, what does obtuse mean? One angle greater than 90, less than 180, right? Isosceles means two of the sides are equal, two of the legs are equal. All right, so we have an angle that's greater than 90, and we have two equal legs, right? That's an obtuse isosceles triangle. How about acute scalene? All angles are less than 90, right? Greater than 0, less than 90. Scalene, no equal sides. So don't mark any of the sides as being equal to each other. They should all be different lengths. This doesn't look that acute to me. This kind of looks obtuse. They did not do a great drawing. But that's your textbook publishers. How I would have done it is more like, that looks kind of like a right angle. Maybe like that, right? So all different sides, clearly obtuse. I would have put my Q here, right? Acute, 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 all different sides, and done something along those lines. All right, so triangle ABC has the following vertices. Classify it by its sides, then determine if it's a right triangle. So the first thing that we should do is just graph it. It just makes life a lot easier. So if we have 0, 0 for our A, our B is at 1, 2, 3, comma 1, 2, 3. Always get into the elevator before you go up or down. We go over to negative 3, 1, 2, 3, and up to the third floor, right? Get into the elevator before you go up or down. So I'm going to connect these and see what we're working with. So we have 3 plus 3, that's a length of 6. That one was easy because it's just horizontal. Now we're working over here. So we have 3. If I make a little triangle, we have a 3 by 3. So just a quick little reminder from Algebra 1. If you have a right triangle that has two side lengths that are the same, it's isosceles, right? Like x, x, x rad 2. Do you guys remember a 45, 45, 90, a special right triangle? 45, 45, 90. It was x, x rad 2. So 3, 3. I know that this is 3 rad 2 without doing the Pythagorean theorem. If I didn't know that, if I didn't remember my special right triangles from Algebra 1, then all I have to do is 3 squared is 9, 3 squared is 9, 9 plus 9 is 18. So we have the square root of 18, which is 9 times 2, which reduces to 3 rad 2, and I get to that 3 rad 2 that way. It's just, if I notice, oh, okay, it's x rad 2, I don't have to do this math over here, okay? So over on this side, we have 3 and 3. So it's going to be the same thing, 3 rad 2. So we have an isosceles triangle, right? This is definitely isosceles, x, x. Is this x rad 2? Is this 3 rad 2 rad 2? Let's look. 3 rad 2 rad 2. Rad 2 times rad 2 is 2, right? Because rad 2 times rad 2 is rad 4. The square root of 4 is 2. And 3 times 2 is 6. This is totally a 45, 45, 90. So I know that this is a right isosceles triangle. If I didn't notice my 45, 45, 90 rules embedded in here, I could just do my slope. Down 3 over 3, or down 1 over 1, down 1 over 1, down 1 over 1. This one has a slope of negative 1. This one right here has up 1 over 1, up 1 over 1, up 1 over 1, slope of 1. 1 and negative 1 are negative reciprocal slopes, therefore it is a right triangle. So this is a right isosceles triangle. There's multiple ways to do these. Find the measure of angle JKM. JKM. We're looking for this measurement right in here. Okay? What do we know? So we actually, during your copy for your notebooks, you should have noticed that there is a new rule. And when we have the exterior of an angle, the exterior angle theorem says that the sum of these two, right? So it's going to equal the outside angle. So the 2x minus 5 equals the 70 plus x. The sum of these two equals your exterior angle. So your exterior angle theorem, the sum of the two non-adjacent interior angles, non-adjacent, not next to it. The sum of the two non-adjacent interior angles equals the exterior angle of a triangle. So not the one next to it, but the other two. Those equal this. Well, think about it. These two are supplementary, and these with this are supplementary. Therefore, these are equal to each other, right? Because these are a linear pair, and triangles add to 180. So they both have that same relationship of adding to 180 with the same other unknown angle, right? Therefore, these are equal to each other. That's where the rule comes from. So if I'm solving for this, I'm going to subtract x from both sides, leaving me of x minus 5 equals 70. Add 5 to both sides. X equals 75, right? So then we're going to plug in. 75 times 2 is 150. 150 minus 5 is 145. Make sense? So we solve our two-step equation. Subtract x from both sides. Add 5 to both sides, and we have 75. We plug it back into what they want us to find. They want us to find this angle, so we plug our value of x, the 75, in here, and we get the 145 for our answer. The tiled staircase shown forms a right triangle. The measure of one acute angle in the triangle is twice the measure of the other. So we know that this is a right angle, right, because it's a staircase. So one of them is twice the other one. So we'll say like 2x versus x, right? Find the measure of each acute angle. All right, well, 180 minus 90 is 90. So these two have to add to 90, correct? So 2x plus x, or 3x, equals 90. So divide by 3. X equals 30. So we're going to have 30, and 2 times x is 60. So it's going to be a 30, 60, 90 triangle. Oops. All right, so we have a 30, 60, 90, which they're just taking a while to show you that. All right, so find the measure of angle 1 in the diagram as shown. So we know that the sum of the two non-adjacent interior angles equals the exterior angle, correct? Correct? So 3x plus 40 must equal 5x minus 10. Subtract 3x. 40 equals 2x minus 10. Add 10. Oops. 50 equals 2x, divide by 2. X equals 25. So now that we know x is 25, 25 times 5, 125. 125 minus 10, 115. What do you know about angle 1 and this angle? They are a linear pair. Therefore, they are supplementary, equal to 180. 180 minus 115, 65. Angle 1 must equal 65 degrees. Make sense? Find the measure of each interior angle of triangle ABC, where angle A is x degrees, B is 2x, and C is 3x. I want you, with your table partner, to try this problem out and ignore the fact that things are not drawn to scale. Your textbook publishers are not that great at making problems make sense. So clearly, if this is 3 times x, why is it smaller than 2 times x? Like, this is acute. This looks like it's possibly a right triangle. That doesn't really make sense that this is a smaller measurement here than there. But okay, let's just do it because that's the numbers they gave. So solve for each angle. All right, so what you should have done is x plus 2x plus 3x, or 3, 4, 5, 6x equals 180. Divide by 6. X equals, oh my gosh, it's acting up. My whole thing is spazzing out. I don't know why. Let's try this again. X equals 30. So we've got to have 30. 30 times 2 is 60, and 30 times 3 is 90. This is a 30, 60, 90, clearly not drawn to scale. Find the measures of the acute angles in a right triangle as shown in the diagram. So here we're going to have 2x plus x minus 6, or 3x minus 6 equaling 90. 90 plus 6 is 96. Do not pack up until I tell you to do so. 3x equals 96. Divide by 3 on both sides. X equals 32. So we're going to have 32 times 2, or 64. And 32 minus 6, 26. Right? And our last one. In example 4, what is the measure of the obtuse angle formed between the staircase and the segment extending from the horizontal leg? So they're saying solve for right here. What is this? All right, well, if this is 2x and x, that's 3x equals 90. So x is 30. So 30 and 60. If this is 30 and this linear pair is 180, 180 minus 30, 150. So your answer is 150. Sorry that my computer is spazzing out, but it is what it is. That is everything for our lesson. We hope you had a great day. Like and subscribe. And that keeps disappearing on me.